My name is Christophe Yao Gadese. I hold MPhils in Mathematics Education. I'm taking you through Math 101, Algebra and Trigonometry. We are starting with Unit 4, Polynomial Functions and Linear Programming. And it begins with Section 1, Linear Functions. Section Objectives. By the end of this section, you should be able to A. Identify a linear function. B. Identify the domain and range of a linear function. C. Draw the graph of a linear function. D. Identify some properties of functions. And E. Find the equation of a linear function. Let's start with relations. And under relations, we will talk about ordered pair. If you have two numbers that are enclosed in a parenthesis with a comma separating them, those two numbers form ordered pair. So if you have, for example, 2, -3 in a parenthesis, then you have an ordered pair. You can also have another ordered pair to be -3, 2. It's a different ordered pair from the first one. If you have ordered pairs in braces or enclosed by curly brackets, that gives you a set. So you can have a set of the first ordered pair, 1, 3, and the second ordered pair, 4, -1. Then you have another set, and in that set, the first ordered pair is 4, -1, and the second is 1, 3. You can conclude that these two sets are the same, since they are made up of the same kind and the same number of ordered pairs. So for a set, the order of arrangement of the ordered pairs is not important. But when you consider an ordered pair, the order of arrangement of the entries in the ordered pair is very important. Let's look at this example. Which of the following are ordered pairs? A. 2, -pi. B. The set consisting of 2, -3. C. 1, 3, -1. D. A set of 1, -5 as an ordered pair and 9, 0 as an ordered pair. Then E. 2, 5. Let's now look at the solution to the question. I hope you have written your answers down. Let's look at it and see if it is the same as what you have. You will see that out of the 5 items given, it's only the first one, that is 2, -pi, which is an ordered pair. The rest are not. The second one, for example, uses braces instead of parentheses, which is a set. The second one has 3 numbers instead of 2. And the third one is a set of ordered pairs. Then if you look at the last one, it's a matter of listing of the numbers. So this will take us straight into what we call relations. You look at the fourth question, which we say is a set of ordered pairs. So if you have a set of ordered pairs, you call it a relation. The ordered pairs can either be listed explicitly or they can be implied. So let's look at the set A. It's a set of 3 ordered pairs. The first one is -2, 8. The second one, 1, 2. And the third one is -3, -5. The set B is made up of 3, 5 as the first ordered pair, 1, 3 as the second ordered pair, and then 2, 4 as the third one. Then the set C is made up of x, y, and is such that y is equal to x. Now, if you look at the examples of relations that we have given, you will note that the third one, which is C, it's made up of ordered pair in which x and y are equal. Some of them are 0, 0, 1, 1, 2, 2, 5, 5, negative half, negative half, pi, pi, and so on. Now let's talk about domain and range. You will see that an ordered pair is made up of two numbers, the first entry and the second entry. So if we talk about the domain of a relation, we are talking about the set of all the first elements of the ordered pairs. Then when you consider the set of all the second elements of the ordered pairs, you have what we call the range. So in most cases, the domain is a set of all x values, and the range is a set of all y values. So let's look at an example. Identify the domain and the range of the relations A, B, and C above. So the examples we have given for relations, this question is based on that. So think about the answers before we get to the next stage. What answers do you have? Let's look at my answers so that we do a comparison. For the first set, the domain will be -2, which is the first entry for the first pair, 1, which is the first entry for the second pair, -3, which is the first entry for the third pair. And then the range will be 8, which is the second entry for the first pair, 2, second entry for the second pair, and then -5, second entry for the third pair. You do the same thing for the set B. You put all the first entries together to get the domain, and then all the second entries together to get the range. Then for C, we'll consider all real numbers as the domain, and then all real numbers as the range. Let's move on to functions. Now, we use variables to represent unknown real numbers. Now, if you put the numbers and the variables together, you form expressions. What are some of these expressions? 3x minus 7, x squared minus 4x plus 4, x cubed plus 2x squared minus 3x plus 4. There are some operations that can be carried out with these expressions. We'll look at those in the next stage. We'll look at the actions that can be taken with those expressions. The first one, values can be given to us, and we substitute these values for the variables, and then we can evaluate the expression. Another thing we can do is to rewrite the expression in its simplest form. This is what we call simplifying the expression. We can also set two expressions to be equal to each other, and then we solve for the stated variable. We can also set two expressions to be equal to each other, and then we graph the equation. So these are the actions that we can take with those expressions we have seen. Let's look at an example where you have to substitute a value into the expression and simplify. Question: evaluate the expression x cubed minus 2x squared plus 3x plus 5 for the following values. A, x is equal to 0. B, x is equal to 2. And C, x is equal to -1. Let's look at the solution. So what we do is that we'll take the first value, which is 0, and we substitute it into the given expression. So in place of x, we put 0. So the expression becomes 0 cubed minus 2 into bracket 0 squared plus 3 into bracket 0 plus 5. If you simplify, you get 0 minus 0 plus 0 plus 5. And this finally gives 5. We take the second one, and wherever we see x in the expression, we replace it with 2. So we have 2 cubed minus 2 into bracket 2 squared plus 3 into bracket 2 plus 5. When you simplify this, you get 8 minus 8 plus 6 plus 5, and that gives us 11. We get to the last one, where we are going to substitute -1 into the expression. So wherever we see x, we put -1. So we have -1 exponent 3 minus 2 into bracket -1 squared plus 3 into bracket -1 plus 5. Now, -1 cubed will be -1. Then -2 times 1 will give you -2. And then when you simplify, you get a final answer of -1. Let's look at a definition of a function. We have looked at relations. There are different types of relations. One of them is what we call the function. And a function is a special relation. This is because it is a kind of relation in which no first coordinates are equal. You can verify whether a relation is a function by using a graphical method. What you do is that you draw a vertical line across the graph. And if that vertical line crosses the graph at only one point, then you know that the relation is a function. Otherwise, that relation is not a function. And we are saying that for a function, no first coordinates, which we call the domain, are equal. No first coordinates in the domain are equal. Now, if you have a function that is of the form f of x is equal to ax plus b, where a and b are real numbers, then you have what you call a linear function. If you draw the graph of this linear function, it is always a straight line. If you study that function, f of x is equal to ax plus b, the a there represents the gradient of the line, while the b represents the y-intercept, what is sometimes called vertical intercept. We will look at how to draw graphs of some of the linear functions. So let's look at example 4. Draw the graphs of the functions f of x is equal to x plus 2. That's the first one. The second one, f of x is equal to 2x plus 3. Then the third one, f of x is equal to -2x plus 2. And the last one, f of x is equal to -x plus 2. And we are to draw all these on the same axis using the domain x greater or equal to -4, but less or equal to 4. Let's look at the solution. We will draw a table of values that will help us to do the graph. So the x in the first row represents the domain given. So it starts from -4 to +4. Then the 4 equations given are included in the table. So let's look at the first one, which is x plus 2. We have already learned how to do substitution of values into expression. So we are going to substitute all the x values, one after the other, into the given expression. In this case, x plus 2. So we put -4 in place of x, and we add it to 2. We get -2. We do the same thing with -3. We put -3 in place of x plus 2. We get -1. We put -2 plus 2. We get 0. We put -1 plus 2, we get 1. We put 0 plus 2, we get 2. We put 1 plus 2, we get 3. We put 2 plus 2, we get 4. We put 3 plus 2, we get 5. And then we put 4 plus 2, and we get 6. So we have ordered pairs now. -4, -2, -3, -1, -2, 0, -1, 1, 0, 2, 1, 3, 2, 4, 3, 5, 4, 6. So we are going to plot these values, and any straight line that we draw will pass through all these values. Most at times, you need any two of these points to get your straight line. So even if you are not able to do all the values, you can still get your straight line. We have decided to use all the values here because of the domain given us. You do the same thing with the second expression. You substitute the values of x into it. You do the same for the third one, which is -2x plus 2. And then the last one, -x plus 2. So at the next stage, we will see the graph of these expressions. These are the graphs of the functions given. If you study the graphs carefully, you realize that the first two have positive gradient. That means that the coefficients of x, which has been denoted by a in the expression that we use to denote functions, linear functions, are positive. So the first one, f of x is equal to x plus 2. The coefficient of x is plus 1. The second one, f of x is equal to 2x plus 2. The coefficient of x is plus 2. So you see that the orientations of the first line and the second one are from the lower bottom of the left to the upper part of the right, the two functions. Then when you look at the other two, the gradients are negative. And so the orientation is from the lower part of the right to the upper part of the left on the graph. And so any graph that has a positive gradient, the orientation will be from the lower part of the left to the upper part of the right. And anyone that is negative, the orientation will be from the lower part of the right to the upper part of the left. And you see that all the lines are passing through the points we have plotted. Let's look at another example. Here we have three graphs. Now take note, if you look at the first graph, the first set of graphs that we have drawn, they all have y-intercept of plus 2. And you'll notice that all the graphs, all the four of them, have intersected at the point 2. So at the point 2, you will see them crossing each other. When we come to this one, look at the y-intercept. The first one is plus 3. The second one is 1. And the third one is minus 3. So you will see that at this stage, the lines will not cross because they have different intercepts. So as we did in the first case, we still have to draw a table to show the values that will give us the ordered pairs to be plotted. So here we have decided to use just few of the values, even though the domain is from -4 to 4. So we have decided to use 0, 1, and 2. And then we have the expressions. So when you put 0 into the first one, you have 0 times 2 plus 3, you have 3. You put 1, 1 times 2 plus 3, you have 5. You put 2, 2 times 2 plus 3, you have 7. You do it for all the other expressions. So you look at the chart and you see that all the three lines have the same orientation from the lower part of the left to the upper part of the right. Then the first one meets the y-axis at 3. The second one meets the y-axis at 1. And the third one meets the y-axis at -3. So this is how the lines look like. Properties of functions. If you are given any two functions, you can add them, you can find their difference, you can also find their product, that is by way of multiplying them, and you can find their quotient, one divided by the other one. Let's look at some examples that will help us understand the properties. Given the functions f of x is equal to 9x minus 3 and g of x is equal to negative 3x plus 5. Find a, f plus g, b, f minus g, c, f times g. So we do the first one, f plus g, which is equivalent to f of x plus g of x, and that is equal to. So we bring the function for f of x, which is 9x minus 3, plus we bring the expression for g of x, which is negative 3x plus 5. Then we will simplify. So we'll have 9x minus 3x, which will give us 6x. Then we have minus 3 plus 5, and that will give us 2. Let's look at the second one, f minus g. So over here, the order is important. We bring the f first before the g. So f of x is 9x minus 3. Then g of x. Because of the minus, we bring the parenthesis. Negative 3x plus 5. Then we will use the negative to open the bracket, so that we will have 9x minus 3 plus 3x minus 5. Then we do 9x plus 3x to get 12x. Then we also do minus 3 minus 5 will give us minus 8. The last one, which is multiplication, f of x times g of x. In this example, we'll consider the first bracket 9x minus 3 and pick the first entry 9x and use it to multiply the second bracket. So 9x times negative 3x will give us negative 27x squared. Then 9x plus 5. 9x times 5 will give us positive 45x. We are done with 9x. We come to minus 3. Minus 3 times negative 3x will give us positive 9x. Minus 3 times 5 will give us minus 15. Now, when we simplify, we will have negative 27x squared. Then we add 45x and 9x to get 54x minus 50. Let's learn how to find equation of a linear function that passes through two given points. Let's do this with an example. And over here, we are going to compare or equate gradients. And so we will learn how to find gradients and then we equate them. Find the equation of the linear function that passes through the points negative 2, negative 5, and 2, 10. So the solution, we will first find the gradient of these 2 points, negative 2, negative 5, and then 2, 10. To find the gradient of a line, you will use change in y over change in x. You can use y1 minus y2 over x1 minus x2. Or you can use y2 minus y1 over x2 minus x1. So let's use the second one, y2 minus y1 over x2 minus x1. So when we take the point P, the first number there, which is negative 2, we make it x1. Then the second number, negative 5, y1. Then when we come to Q, the first entry there x2, the second entry y2. So we substitute those values into the formula. So y2 we have 10, then minus y1 which is negative 5, over x2 we have 2 minus x1 which is negative 2. When you simplify, the numerator becomes 15 and the denominator becomes 4. So that is one gradient. Then what we will do is that we will consider an arbitrary point on the line and name it x, y. And then we will find the gradient of that arbitrary point and one of the given points. In this case, we want to use q, which is 210. So change in y over change in x. So y minus 10 over x minus 2. Now we are going to equate these two gradients to say that y minus 10 over x minus 2 will be equal to 15 over 4, which we will simplify at the next stage. We continue with the solution to the problem, and over here, after equating the two gradients, we will do cross multiplication so that 4 will multiply y minus 10 and 15 will multiply x minus 2. Then we use 4 to open the bracket to have 4y minus 40. And then we also use 15 to open the bracket at the right hand side. We have 15x minus 30. Then we'll move the 40 to the right hand side. So we have 4y is equal to 15x minus 30 plus 40. And when we simplify, we get 4y is equal to 15x plus 10. We can divide through by 4. So y will be equal to 15 over 4x plus 10 over 4. And therefore, the function for the function for the line that passes through those 2 points, f of x is equal to 15 over 4x plus 10 over 4.